This is the GMAETS 41 Support Student Education Initiative Program. You are welcome to our chemistry class. In this video, we are going to look at part 2 of this topic, valency, formation of compounds and chemical formulae. In our previous class, you would recall that we treated how we can write the correct chemical formulae for binary compounds using the knowledge of valency. Binary compounds are compounds that are made up of two elements. Now, in part 2 of this topic, we are going to see how to write the correct chemical formulae of a compound. Our focus now will be trinary compounds. What are trinary compounds? Like the name goes, tri, a compound that contains 3 elements. So, how can a student be able to write the correct formulae of a compound that is made up of 3 elements? Very important. You know, the foundation of this topic, I've already stated how important it is for a student to be able to write the correct formulae of a chemical compound. In that way, balancing of chemical reaction and many other things in chemistry will become, should I say easier? Yeah. So today we'll focus on trinary compounds, okay? How can we write the correct formulae of a compound that contains 3 elements? On the board here, I've got this short note to tell you what we need to know, the secrets, alright, that would help you be able to write the correct formulae of a trinary compound. Usually, every trinary compound is made up of what we call a radical and then a particular ion, alright? Could be a cation or an anion. Remember what I said, every trinary compound is made up of what? A radical. Look at it. So I'll say that in the formation of trinary compounds, radicals usually combine with other ion. So this should be usually combine, not combines. English. Alright, so radicals usually combine with other ions so that this trinary compound will be formed. Now, you know from our previous class, we explained that radicals is simply a group of atoms that forms what? A single unit. Usually you have 2 atoms of different elements, they come together, form a group. And then that group would give you just a single unit. That single unit usually contains 2 atoms. So that 2 atoms now, which is inside a radical, or which makes up radical, will now react, alright, with another ion to make it 3 elements in one compound. So it's very important for us to know the valencies of radicals. Once we are able to understand that concept, then it will become quite easier for us to see how trinary compounds are formed. So that next time, if you want to write tetraoxosulfate 6, you'll remember that it is H2SO4, that it is not HSO4. If you want to write lead 2 trioxonitrate 5, you would know that it is Pb open bracket NO3 close bracket 2. That it is not Pb NO3. Are you ready? So please come along with me. We have on the board here common radicals, their names, and of course their valency. One of them we have here is NH4+. The name of this NH4+, that radical, is called ammonium ion. Ammonium ion. So don't forget that. And the valency, just like you can see there on the board, is +1. You can say that here. Okay? Another one is CO32-. CO32-, the name is trioxocarbonate 4 ion. And what is the valency? Of course, you can see that. -2. Taken from here. Then we have SO32-, trioxosulfate 4 ion. The valency is -2. What about SO4 2-, tetraoxosulfate 6 ion? The valency again is -2. Then we have NO3-, the trioxonitrate 5 ion. The valency, as you can see here, is negative, so it's -1. We have the hydroxyl ion, OH negative. Sometimes we can call it hydroxide ion. Is that okay? -1 is the valency. So it's very important as a chemistry student to be able to remember the valency of these radicals so that you can be able to write the correct chemical formulae of a compound that is made up of these radicals. Let us quickly look at an example here, okay? Let me put something downward here. Just imagine if you hear calcium trioxocarbonate 4, it's written as CaCO3. Why is that compound written like this? But if you hear sodium trioxocarbonate 4, it's written as Na2CO3. So why is it that in the case of sodium we have 2, atomicity of 2 here, but in the case of calcium we don't have that atomicity of 2. The atomicity here is 1. What's the reason? So we're going to use our previous knowledge for binary compound, formation of binary compounds, okay? Apply it here, deal with interchange of valencies, okay? And see how this trinary compound is obtained. I know that you are prepared for that. And that is what we are going to see next. When two ions, one a radical, the other one, either a cation or an anion, combines with the radical, they interchange their valencies, then we see the compound that is going to be formed. In this video, let us use the knowledge of radicals and interchange of valencies to write the correct chemical formulae of a trinary compound. We are going to start first with a compound known as tetraoxosulfate 6. When you hear tetraoxosulfate 6, how is it being written? First of all, you should know the elements that make up this acid. Okay, how will we get to know the elements? Listen, tetraoxo, you heard oxo telling you that there is oxygen there. Sulfate, you've heard something like sulfur, of course. There is sulfur there. Now, it's an acid, okay? So from what I pronounced, you heard the name of 2 elements. That tetra is just a number. We'll still deal with how we give the name of compounds, okay? Our interest now is to see how we write the correct formulae of a chemical compound. So from the name here, you've heard 2 elements. What is the 3rd element? Remember, tetraoxosulfate 6 is an acid, and every acid contains hydrogen. We're going to treat that under acid, base, and salt. So please, let us do this and see. Tetraoxosulfate 6. So it contains 3 elements, hydrogen, sulfur, and oxygen. Now, the sulfate 6 is the sulfate radical. That is SO4 because it had tetraoxo. So it has the SO4 2- radical. Of course, combining with hydrogen. So this is what we're going to get. Formation. The first one is a formation. Okay, let's see number 1. Formation of tetraoxosulfate. Sulfate 6 acid. Okay, like I said, the compound contains hydrogen, sulfur, of course SO4 2-. These are the things it contains. Hydrogen ion, and then the SO4 2-. So we're going to use this to see how the compound is formed. Tetraoxosulfate 6, is it just HSO4 or is it something else? We're going to find out and see. So we'll start with hydrogen ion. Of course, from our previous class, we already explained that the valency of hydrogen is what? +1 in most cases. Alright? It could be -1, that is when you have it as a hydride. When hydrogen reacts with metals, it assumes negative, but mostly it's positive. So in this case, it's positive because it's reacting with negative ion. So this is going to be combined with SO4 2-. Now, during the process, what is going to happen? They will interchange their valency. So SO4 2- will step down its valency to hydrogen. Hydrogen will step down its +1 valency to the SO4 2-. So this is what we are now going to get. H, these 2 has been stepped down, so it becomes the atomicity of hydrogen. Then you now have SO4 remember that hydrogen gave 1 to this SO4, and usually we don't show 1. I've said that before now. So you see how tetraoxosulfate 6 acid is being written. Therefore, never you write tetraoxosulfate 6 like this, okay? We didn't do that. This is very, very wrong. It's very, very wrong. It's always H2SO4. Let's look at the next one. Formation of calcium trioxocarbonate 4. Alright, now what does this compound contain? Let's think about it. Calcium trioxocarbonate. So you heard calcium, you heard oxo, you heard carbonate. That carbonate is carbon. So it contains calcium, Ca. Is that okay? And of course calcium, the valency is 2+. We studied that previously. Then we have the CO3, 2-. These are the ions present in that compound. The radical here is CO3, 2-. So let us see how calcium trioxocarbonate forms. What is the correct chemical formulae of this compound? So it's going to be the combination of calcium 2+ combined with CO3, 2-. And of course, you know there's going to be interchange of valency. So let's see. CO3, 2-, we step down its 2 valency to calcium. Calcium will also step down its 2 valency to this CO3, 2-. So we expect to get calcium. Now 2 will come over here from this CO3, 2-. Then CO3, take note that calcium will also give 2 to this CO3. Now, you have their valencies here as 2, 2. So what really happened is, it's as if there is going to be a division through. That common number, which is 2, 2, will divide through. So even if I fix up 2 here, 2 will divide through, have 1, 1. So you see why we don't usually put a number here. Apart from 1, what you have here is 1. The atomicity of calcium there is 1. So this is the correct formulae of calcium trioxocarbonate 4, CaCO3. Is that okay? Can we think about this compound? Let's see, formation of ammonium chloride. Okay, so when you hear ammonium, of course, you want to agree with me that the ammonium ion will be present. So we'll have NH4+. And of course, you heard chloride, which is from chlorine. So you say this right? Now when they combine, what's going to happen? You notice that the positive ion always comes before the what? Negative ion. I hope you notice that. Hydrogen is positive, SO4 2- is negative, calcium is positive, CO3 2- is negative. So the positive always comes before the what? Negative. So you're going to have NH4 positive combined with Cl negative. So let's see what this is going to be. Of course, there's going to be interchange of valency. You don't need to be drawing all this interchange of valency. Let's assume you're answering exam question. It's really not necessary drawing that. As you're learning this now, just understand the principle. I'm drawing all of this so as to show you what really happens in the process. So this is going to be NH4. Now you notice that the chloride ion is stepping down 1, and we don't usually show 1. I've said that. You notice that here I did not write any 1 here. When the 2, 2 cancel out, alright, to give you divide by 2 became 1, 1. You don't show atomicity of 1. So NH4. Now this plus ammonium will transfer to chlorine. So this becomes something like this. So you see that, right? Ammonium chloride. This is how we write it. This is how we write ammonium chloride. Okay. Finally, let us look at the formation of lead 2 trioxonitrate 5. Lead 2 trioxonitrate 5. Now, did you listen to the compound name? Lead 2 trioxonitrate 5. So lead, you heard lead. Lead is Pb. Now, trioxo, you heard oxo, which is oxygen. Nitrate. Nitrate is nitrogen. That's from nitrogen. It simply means that we have these elements or ions present. Lead, which is the valency of lead, is 2+ in most cases, okay? Could also have it as 4. But in most cases it's 2. In this case it is 2. So we have Pb 2+. And then the radical there is NO3-. That's the radical. So let us see how the combination leads to the formation of the compound and get to know the correct chemical formulae of lead 2 trioxonitrate 5. So we go. Pb2 plus is going to combine with NO3 minus. So let us see what happens when they interchange their valencies. So this -1, that's a 1 will be transferred to this. So the atomicity of lead here is going to be 1 in the product. And then lead will give its 2 to this NO3 minus. So the atomicity of NO3 minus will become 2 in the product. So look at this. Pb, atomicity is 1. We don't show it. Now NO3. NO3. Take note that the 2, the valency of lead, which is 2, that steps down to become atomicity of NO3 here, will be affecting both nitrogen and oxygen. It will be affecting all the radical. So that's all the elements in the radical. So you enclose it in brackets and then you put 2 outside. So this is your lead 2 trioxonitrate 5. Lead 2 trioxonitrate 5. You would notice that if it were to be sodium trioxonitrate 5, for example, sodium, the valency is what? 1. The radical NO3 minus, the valency is what? 1. So when they interchange and combine, you have NaNO3. NaNO3 for sodium nitrate. So, dear friends, I hope that the GMAETS 41, through this Support Student Education Initiative program, has given out something wonderful. This is the foundation of chemistry. Very important that students appreciate these topics. As we've done that, make sure you go through them. We will be using all these concepts to do a lot of things in chemistry subsequently as we continue in our class. Next, we are going to see when we talk about balancing of chemical equation.